Good morning, Algebra 2 students. I hope that you're doing well. Here we are, finishing up Chapter 6 today as far as new material. I hope that these videos have been helpful to you, and do know that I continue to pray about you and kind of see your faces as I'm teaching these things. So just keep on reaching out to each other and keep on working, and your guys are going to be in great shape finishing out this year as far as the algebra goes. So I'm really proud of you for the work that you're doing. So keep up the good work, and let's get right into it as far as looking at yet another type of graphing. Now you'll notice that even from back at the beginning of the year, there are certain things that have continued to happen, whether it be that we're shifting it left or right or up or down or stretching or compressing. And way back when we were dealing with the absolute value functions, it was something brand new, but by now it should be getting to the point where it's settling in and you just kind of expect it to happen with each new parent function. So I want to take a look today at the cube root parent function. Notice that I've strategically chosen some x values to give us our basic parent function and what it looks like, because when you have a cube root, you're looking for numbers that are going to very easily be able to find the cube root of. Okay, so for example, the cube root of 0 is 0, because 0 times 0 times 0 equals 0. The cube root of 1 is 1, because 1 times 1 times 1 gives you 1. Cube root of 8 will be 2 for the same reason. 2 times 2 times 2 is 8. And then we have our negatives to go right along with them. This being -1 and this being -2. Remember, cube roots don't have really as many restrictions. The domain of this function, for example, would just be all real numbers, because there's nothing that you can't take a cube root of. The positives, the negatives, they all have a value, even if it's something that's some kind of crazy long decimal that doesn't end. There's still an answer for each one of them. So if we take those and we put them on a graph, okay, here's your 0, 0, here's your 1, 1, here's your 8, 2, and you've got your -1, -1, and your -8, -2. We end up having this sideways graph that looks suspiciously like a cube graph, but just turned on its side, because remember that they are inverses. So it's really just flipped around an axis from that type of graph that we took a look at before. So once again, since we have a new parent function, it follows the same rules. This lesson doesn't have to be really terribly long, because it follows the same rules as what we've seen before. So if we're looking at a new function that we want to graph, okay, it is a function because it does pass the vertical line test. We still need to throw that in there as a little bit of a review. We have a 2, x plus 1, minus 4. So you need to interpret what each one of the things is telling you to do. We're going to start with this one. Step 1, this one tells us we're going to multiply all of these values by 2 to find out what the stretch looks like in this graph. So you'll take each y value and multiply it by 2. 0 times 0 is 0, but 1 times 2 is 2, and 2 times 2 is 4. So what the first 2 here has an effect of doing is stretching it out. Okay, we know that we're expecting a vertical stretch, but this is what that stretch looks like. Stretches it out, stretches it out. And if we were to just have that 2, you would see that it just kind of widens it in the y-axis direction. But then after that, we have the other instructions with h and k, where this one takes it left 1 and this one takes it down 4. So left 1, down 4. So you'll go point by point, left 1, down 4. Left 1, down 4, and you'll count them point by point. And when you do that, left 1, 1, 2, 3, 4. Left 1, 1, 2, 3, 4. left 1, 1, 2, 3, 4, and you can see that our new graph is stretched. Okay, it's not as flat, and it's moved over and down. So a lot of times on these graphs, if you have the parent function handy right there, and then you do it step by step like that, it really doesn't come out to be too hard, but you've got to keep in mind what you're doing. Your other alternative for this would be to pick a random set of points, but the problem with that would be when you're trying to find this key anchor point where everything revolves around it, because you really, really need to have that to have the best idea of what's happening with the graph. So if for nothing else, even if you want to make a list of ordered pairs, always start with these things so that you can tell where that anchor went, so you can get a good idea of what's happening to the right and to the left of it. All right, so you can do this by counting, and that's what we're actually going over today. So another thing that you can do is that if you have a radical function, you can actually rewrite it. Look for some things that are hidden ways to simplify this first. I mean, this looks as if it's something that you can't really just take anything out of, but keep in mind that you can always look to see if anything has a GCF, and that can help you. So for example, 9 goes into this and 9 goes into that, and maybe some red flags go off in your head. Wait a minute, that's a perfect square, and that should help you out actually, because when you factor out that 9, here we go. When you factor out that 9 on this step, 9 times x, 9 times 2, the square root of 9 is 3, so that piece can come out and x plus 2 can stay in. You already have an idea of what the original graph looks like, and I'm not actually graphing it now. It just says to rewrite it and describe the graph. So it comes from the parent function, square root of x. You should have in your mind that it starts at 0 and goes up and to the right, kind of curving nice and flat. There is restricted values, so you've got that in your head. But as far as where it goes, this part right here will tell us that it goes left 2, and this part right here will tell us that it has a vertical stretch of 3. Okay, the parent is this, so you need to identify the parent. You need to talk about what each one of the numbers in here actually tells you. Now, without factoring it, you can't actually tell what is really happening. So for now, we're having nice convenient ones that will simplify so that you can identify a very specific parent function. Okay, so you identify the parent, what the graph comes from, tell what the numbers are telling you. Stretch 3, left 2. And this should look very, very familiar to you because it's exactly the same as we started back with the absolute value functions. I think it was chapter 2. That was a long time ago. All right, let's look at another one, cube root. Okay, so you're seeing cube root. You're thinking it's probably based off of a parent of cube root of x. But we need to simplify this first. It should pop out that there is a greatest common factor of 8 here, which should somehow ring some bells that, wow, that's a perfect cube. That's going to be really convenient. So what you'll do, you factor out that 8, because 8 times x is 8x. 8 times 4 is 32. You can try to cube root the pieces. So the cube root of 8 is 2, because 2 times 2 times 2 gives you 8. Now you have a function that's in a good form based off of a specific parent. Our specific parent, think about it, is the cube root of x. This 2 tells us something, and it should be popping in your head that this 2 would tell us that we have a stretch of 2, vertical stretch of 2. This 4 should be telling you that it goes left 4, and this 2 should be telling you that it goes down 2. So here's our parent, stretch 2, left 4, down 2. That's really all I have as far as new material today. You do need to make sure that you're getting ready for your quiz. We're going to do a quiz on sections the 5 through 7, and that will be on Thursday. Tomorrow we'll review a bit for that. Then when we get back from Easter break, we're going to review and jump pretty quickly into your Chapter 6 test. You will have at that point received your quiz back, and hopefully you'll be given an opportunity to make sure that you ask all of your questions that you may have, and then be able to take your test successfully. Like I said, I'm proud of you. If you've made it to this point in the video, it means you're really doing a great job, so good job. And I look forward to seeing you sometime. God bless you. God bless your family. Stay safe and stay protected.